And what a topic to finish the day on, right? Ensuring data mobility and consistency with cloud native databases. And ultimately, I'm going to be talking a little bit about backup. But with backup, we can do a lot of good things. So 3 things from that title. One is data mobility. How can we help move workloads from A to B? If you were in the Canister session earlier that Daniil did, he was talking about an open source project called Canister. I'm going to touch on a little bit more detail around Canister that enables us to move those workloads in a consistent fashion. And we're going to touch on the vast majority of, or the vast plethora of databases that we have available to us in our cloud native ecosystem. It used to be traditionally we'd have an Oracle server and we'd throw as many databases on it as we possibly could because we've paid a big license for it. Now, in the cloud native world, we can pick and choose the right database for the right job. Okay, so what is mobility? And mobility is about how can we move from, say, one Kubernetes cluster to another, and that means the application. So that application, as you're all probably aware, could consist of multiple deployments, stateful sets, services, ingress, all of the different Kubernetes objects that make up that application, including PVCs and all of our different data services as well. And I want to take that from maybe an EKS cluster, and I want to move that to OpenShift, or OpenShift to EKS, or on-prem to somewhere else. Like, I just need to be able to move that from A to B. And really that starts from a consistent point of view, but I have a goal to move that somewhere. And that might be migration. That might be because I want to glean some information from that data in maybe a public cloud where I can use some sort of BigQuery against that, or a BigQuery equivalent, to understand a bit more about that data. So the other phenomenon that we've seen over the last 12 to 18 months is the project called KubeVirt, and actually seeing virtual machines land on Kubernetes. Mind blown a little bit to see that. I come from a virtualization background, so to see this is an amazing feat. I think we're at version 1 of KubeVirt. If we look at other adoptions of KubeVirt, with OpenShift virtualization probably being the most prominent, but then you've got SUSE and their Harvester project as well. So now we've got both our container or our microservices applications plus databases all on the same compute, storage, and networking. And that adds some complexity when it comes to mobility, protecting, and disaster recovery for that as well. So what is consistency? So like I mentioned, I've got an example app here. It's actually called a K10 app. Pretty similar. We've got like an authentication service, we've got an order service, we've got a catalog. They're all linked up into our favorite databases for that job. So we've got MySQL, if you can see at the back. We've got Postgres, and we've got Mongo. We can also include things like RDS or external data services that aren't on the Kubernetes cluster. And we often hear the term stateless quite a lot within our Kubernetes cluster, but no one's really running static websites just from their Kubernetes cluster. It's going to be connected to some sort of data somewhere. And that might be an RDS instance, it might be a virtual machine running our databases, and that's where KubeVirt really plays a massive part of that. But what does consistency look like? Is yes, we've got the ability to go into MySQL and we can write a great script for MySQL, for Postgres, for Mongo, and we might have another 10 databases to make up our application. And scripts is one way of doing that. But the challenge there is that, well, we've got this overblow of all of these different scripts that we have to now manage and have version control of that. But equally I need to be able to protect all of the authentication service and everything that goes into that, the service and everything around that. So consistency, application consistency, starts from all of that application namespace plus the data services in one place, so that I can take that and I can recover it somewhere else in that same state as it was. And if you've got a database that's got 1,000 transactions a second or more, then just taking a backup of that PVC and hoping for the best isn't going to be consistent, because you're probably going to lose some of those potentially massively important transactions, especially if it's that order database that we see down the bottom there. So we could use native tools such as PG dump on our Postgres, and that will get us a consistent dump of our database. Now, PG dump at scale is going to fall over. It's not going to be performant. It's not going to give us that copy, a good clean copy of that. So we need to think about also orchestrating that whole service together so that we're looking at the whole application. Just to go back to virtualization days with that Oracle server that I use as an example, we might have an Oracle cluster, and in order to make that consistent, we're going to talk to all of the nodes or one of those nodes that is acting as that primary, and we're going to pause our I/O, and we're going to then take that back up and potentially cache that data somewhere else. Just pause for the picture. So we could write scripts, and that will be our first endeavor. It was when I started as a sysadmin, was how do I write a script to make this a backup? And that's great until you have to recover, because now I have to use this script to recover, I have to use this script to recover, and we're out of sync. Consistency is blown apart. In the Kubernetes world, it's not just about getting this PVC back up and running. We're going to have to now worry about what does the database pod look like as well? What does the application look like? How do we connect all of the dots to make it come back up as we want, whether that's a migration or a recovery? So when I talk about mobility, I talk about mobility and recovery in the same breath, because ultimately migrations is a form of recovery, if you will. So how can we be consistent? Well, we want some sort of schedule orchestration. This goes back to that canister project that Daniil spoke about earlier. It's an open source project that we donated to the CNCF in the fall of last year, so KubeCon in Chicago. And what this gives us is the way in which we can take those scripts and we can put them into what we call blueprints, and that will enable us to use the right blueprint for the right data service. And that includes things like Azure SQL, Amazon RDS, and really that blueprint framework gives you the ability to write whatever you want. Canister is an application framework that enables you to write the blueprints for your application, your data service. And that enables us to be application consistent. It allows us to schedule and orchestrate that. And like I mentioned, it works with external data services as well. So when you hear, I only run stateless workloads in my Kubernetes cluster, you probably have some sort of connected data service somewhere that's associated to that overall cluster. As I mentioned, so Canister, CNCF Sandbox project. We have some community blueprints already out there that I've mentioned already, like around Postgres, MySQL, but also those other services around things like Elasticsearch, Amazon RDS, Microsoft SQL Server in Kubernetes. Anyone using Microsoft SQL Server in a container? No, didn't think so. But equally around operators as well. So K8 Sandra, we've got Crunchy have an operator, because operators have built-in tools like PG dump, but they're a little bit better, a bit more robust. So why not use a blueprint to not only capture or instruct the operator to take that consistent copy? The other thing that we're seeing is other asks around other databases, and that might be things like PG Vector in Postgres for the AI buzz that's absolutely happening, but also looking at other blueprints within the community with vector databases like Weaviate, Milvus, Pinecone. But really think about any data service external to your Kubernetes cluster or inside your Kubernetes cluster. A blueprint framework can be used to protect that. I've actually written a community blueprint that will trigger various different weird and wonderful things out there in the world. One is GitHub backup using an open source project called GitHub. And basically that goes and grabs all of my source code from my GitHub repositories, including issues, including discussions, wikis, all of that important stuff, so that I can then restore that either to GitLab or to another source code repository service out there as well. Because again, it's a SaaS, but GitHub as a service is a SaaS service, so it's your responsibility. I don't think we talk enough about backing up SaaS-based workloads such as that. From a cloud-native database point of view, I mentioned around Oracle or Microsoft SQL. We'd bend all of our applications to store our data on that because we've paid a big license to Oracle or to Microsoft for those clusters. In the cloud-native world, we have a bit more choice, and sometimes maybe too much choice. You'll see on here DB2, anyone running DB2, IBM DB2 from the 80s in Kubernetes? It's there, it's on the CNCF landscape. Microsoft SQL, as I mentioned, Oracle were on there. I think they still are. Anyway, but there's a lot of different choice for different variations, NoSQL, SQL, vector databases, operators, graph database, you name it, there's probably an option on there, and it's really about choice. And that's great. CNCF offers a lot of choice, and that becomes a great thing, but also an overwhelming thing as well when it comes to protecting these. So what is a cloud native database? So it's a database that is designed to take full advantage of cloud technology and distributed systems. Again, I've hammered this a few times already, but Kubernetes is not ready for stateful applications as a misconception, a myth. And I think we could argue that over the last 2-3 years, with the adoption or the evolution of the CSI, so the container storage interface, this enables enterprise storage to actually provide that storage layer inside of our Kubernetes cluster to store stateful workloads, whether that be a choice that people are making or whether you use that external. But I would say the last 2-3 years, that maturity is only grown. And when you look at enterprise storage solutions such as NetApp, Dell EMC, Infinidat, you can name so many, they all have a CSI driver that enables you to store data on them. And that's why we're myth busting on that Kubernetes is ready for that storage and that stateful workload. Cloud native deployment, so what we're seeing out in the field, 3 different options, and I'll touch on where these are kind of weighted. I would say probably most of the customers that I speak to are they've got their Kubernetes cluster and they're connected into some sort of external data service, whether that be a virtual machine, whether it be Amazon RDS, Azure SQL. I feel like I've said Amazon RDS far too many times today already. Or you've potentially got a separated Kubernetes cluster just for infrastructure tasks, such as data storage. So you might have your application in a stateless cluster that is auto-scaling up, down, and everything that we get from native Kubernetes. But you might be using a fixed Kubernetes cluster just for infrastructure tasks, just for storage. And then the other one is, well, let's throw it all inside the same compute and the same storage, the same cluster, because that means that the database is closer to your application, meaning that we get rid of all of that latency. I think there's one more to add in here, and it kind of falls in this first bucket, is around virtualization on Kubernetes. Is imagine that virtual machine is also sat on that same cluster. And a lot of people are looking to how do we migrate our databases, and it might be that Oracle VM that we've rammed all of our databases on, because it's hard to decouple that, especially in a high velocity transactional workload. Like, it's hard to decouple that and start putting that into our own data services. So the quick win is let's get it as close as possible to the application inside one of those buckets. Okay, so what is that consistency spectrum and what does it look like? So we can take storage snapshots. There is no awareness at all to what the application is. If you've got that fast transactional workload, doesn't matter, we're just taking a storage snapshot. So very easy to write a script. Actually, doesn't need to be database aware. So we're just going to take a point in time snapshot and hope for the best if we ever have to restore from that. We've also got the app consistent, and this is where PG dump comes in. As an example, MySQL dump or MongoDB have native tool sets as well, which is actually going to freeze that data service. We're then going to storage snapshot, and then we're going to unfreeze the data service and start the system backup. DB consistent uses those logical dumps, just those logical dumps. We're not bothered about the rest of the application. And system consistent or application consistent, I want all of my YAML manifests that make up my whole application. I want my deployments, I even want my namespace, I want my config maps, my secrets, my PVCs, everything all in one, and I want to also make sure that that data is in a consistent state. And that's really where you want to be. So DB consistent will be where that canister comes in. Canister as a standalone tool will get you so far. It takes away that complicated script writing and script management. Where we really want to get to is an orchestrator of that. And that's where Veeam Kasten for Kubernetes comes in. Proprietary tool, but uses canister, so I'll get to that. And really that focus is around backup and restore of that workload, our first and foremost conversation with all customers, and that's really protecting. And ransomware attacks is always top of mind, it's always in the news, but I still argue, who here has dropped a database before in any production setting? Right, someone's lying. Because accidental deletion is still probably one of the biggest reasons why you ever have to recover any workload. So data loss, corruption, but equally, what happens if I lose my CI/CD tool chain that pushes that application back in? I will mention that for both Canister and Kasten, we've got the ability to integrate into your GitOps pipeline. So I've done sessions on integrating backup into Argo CD, for example. Disaster recovery, how do I get, like, this cluster is on fire, hopefully not figuratively, but maybe it's underwater. And over here, I've got a brand new cluster that I'm going to build because I'm using infrastructure as code to build that out. We can use Veeam Kasten to bring that application back up in a consistent fashion so that you can carry on working if anything was a disaster to cause that. And then probably the biggest talk track and the biggest differentiator for us is around that portability of that application, being able to take you from OpenShift as a complete, consistent application from maybe we started kicking the tires with Kubernetes on-prem and we built a load of virtual machines, and now we're growing up and we want to take away some of that overhead. We want to move to something like EKS or OpenShift somewhere, Rosa or ARO. Or maybe you're expanding and you've got other applications that use other Kubernetes managed services or to that degree. So what that application portability means is that we're going to pick that up from an S3 bucket backup and we're going to restore that somewhere else in that consistent fashion. Now, mobility can mean recovery, but it also can be, well, I'm actually wanting to move that over there from a migration point of view. It could be that I just want to glean some information out that I want to use an external service. I used BigQuery earlier to glean some information maybe out of my data set so that I can quickly spin it up, get some information, throw it away, and be very mindful of those costs. So, I don't know, what's the time? Okay, we're good for 5 minutes.
We are, I'm so sorry, I was tweeting.
Awesome.
And, well, officially we are,
I thought it was at time.
Yeah, well, we're at 4, well, we're not finished yet. We are at 4:35 is what we have, so you have 10 minutes.
Loads of time. We'll hammer it. It was only 47 slides left, so we'll be fine. Okay, so how does Veeam Kasten for Kubernetes work, and how do we use then Canister, that open source project, to enhance that application consistent backup of our data? One, we're deployed either from an operator hub in both OpenShift Operator Hub or Rancher Marketplace or any of the public clouds, or a Helm chart deployment. When we're deployed, we become part of that Kubernetes cluster. We work on custom resource definitions, CRDs, as well as aggregated APIs. We dynamically discover any new application that has been deployed inside of that cluster and everything that makes up that application. We then can create policies that protect that application, and then we can restore anywhere, as I've kind of touched on. So Discover like I mentioned, we become part of the Kubernetes API at that point. Those CRDs, you can interact with those in any of the tools that you currently use. That could be kubectl, that could be anything that interacts with that API. We've also got a pretty funky UI that allows more the operator side of the house that likes a UI versus getting into the CLI to be able to manage those applications and the policies that go with that. We're then going to protect that. Now, we protect it in two ways. We protect using that CSI volume snapshot class that is associated to the storage, and then we're going to export that out. We're going to export that out into either AWS S3, S3 compatible, Azure Blob Storage, Google Cloud Storage, NFS, and a few other different location profiles. And what that really enables us to do, so a snapshot is not a backup. Some snapshots are very durable, EBS snapshots, for example. But by being able to send that off-site into a different location, it means that we've got the capability about being able to recover that if that production storage system was to break, for example. Snapshots go away if that production site is no longer available. So we create a copy of that data, we export that out into our location profile in a consistent fashion on a schedule. And then that restore option. Now, one of the key parts of that restore option, if you've been listening along, you'll be going, well, what about the storage in AWS is different to the storage in Azure, as a simple example. Or there's some other bells and whistles on top of different Kubernetes distributions. So what we have inside of that restore capability is the ability to transform what that application looks like as it gets into that target location. And that could be as simple as just changing the storage class that we're sending it to. It could also be changing the amount of replicas that we're going to bring up. It could be changing the container image version that we're running as part of that, just to test, see what this looks like in EKS, for example. So we can do a lot of powerful things when it comes to that transformation, that restoring anywhere, in a coordinated fashion. So what that's going to do is going to bring everything back, and it's going to transform on the fly, and it's going to enable you to bring new objects or change objects as you're recovering into. Just a bit, I mentioned around how does Kasten get deployed, and Kasten is deployed on your cluster. So for every cluster that you have, there is a K10 deploy or a Kasten deployment. And that looks after that particular cluster. Now, what happens if you've got 100 clusters? We saw, I think it was Taylor potentially saying about the explosion of Kubernetes clusters. And let's say you've got 100 Kubernetes clusters, you've got 100 instances of Kasten now protecting all of that particular cluster. We have something called our multi-cluster dashboard that federates all of them together using Kubernetes RBAC as well, or external authentication services such as Entra ID to be able to federate all of that protection. We can set global policies, we can set global profiles, so that if you've got MySQL and maybe there's well, we integrate into Kyverno and OPA as well, so that you can put guardrails in place to say, well, if you've got a stateful workload in any of your clusters, they must have a policy associated to them as well. I know Numata are actually delivering a session there, but you chose this one, so you won't hear about Kyverno. But we integrate into a lot of the ecosystem tool sets as well. We're agnostic. So the big part about this is that we're agnostic. We're deployed via that Helm chart. It's you bring your own storage, you bring your own physical infrastructure, or your managed Kubernetes service, whatever Kubernetes distribution that you use, and then you create your application blueprints or use the examples and doctor them to whatever you need, and then you're able to then send it out to object storage, NFS, or even a Veeam backup target. So if you've got an existing virtualization estate that is using Veeam to protect the virtual machines in vSphere, for example, then you can leverage that investment that you've made to store those backups there as well. Mobility again. So let's say that we started day one OpenShift cluster on-prem, and we want to get to cluster 1, 2, 3 down the bottom here. You'll see the OpenShift again. Maybe that's Rosa. We've got Amazon EKS. We've got GKE. We've got AKS. We've got Talus Linux. If you haven't heard about that, it's a pretty cool, secure Linux distribution. And we've got the ability to take that S3 bucket, connect it to any of these where Kasten is installed, and restore that application as we see fit on a schedule, either from a disaster recovery point of view, so hit the button, everything comes up, or maybe it is a planned migration or a planned use case for that. Can't fit all of the different Kubernetes distributions out there. That's just a footprint of that, and they've only chosen a few down there. But really, we support Kubernetes going back a few versions as well. Everything's backwards compatible. Yeah, and that's me done, clearly. Is there any questions? Was that too many slides? No. Right, it's beer o'clock then. Ah.
Yeah, I have a question.
Okay.
Do you have a
No worries.
Let me know, shame me later. But do you have a way to easily tie your data snapshots to the rest of the snapshot of the code base that it's supposed to run on?
So
I'm thinking of full backup solutions. I'm thinking about the scripting days, right? You started off with these slides saying, should we use scripts? No, don't do that. I mean, you can, but like PG dump, MySQL dump, or whatever, right? Okay. But often, like, that mapping was done between the state of the application that was deployed and the dump or whatever by just a naming convention of naming that dump whatever version you have running. Do you all have tools for that? Do you still recommend that kind of convention? Yeah.
So great question, because a lot of people have put a lot of time, effort, and blood, sweat, and tears into said scripts. We can take those scripts and put them into that canister blueprint and just continue as normal. And you're going to get the added benefit of them being able to offload that out into S3 rather than potentially a local NFS disk or so. And then along with that, we're going to get the whole application consistency. If you then wanted to hit your source code repository as well, then you could have a blueprint that does that using what I mentioned around GitHub as well.
Gotcha.
Cool.